Okay, let's move on. We are going on to number 3 and number 4, which is right underneath all this mess that we just finished. So certainly not a bad idea to have scratch paper for this. So I'm going to erase, get rid of all this. And it says, find the explicit formula for the function. We did that. Okay, find the domain and range of the explicit formula created in problem number 3. So let's just write that back on here without all the mess. Plus 1. Okay, so now we're looking at the domain and range of this function. And I'm going to get rid of this too, just to give us a little bit more room because we're going to have to graph it on 5. Okay, so purple. All right, the domain for this, remember domain is x. So we need to think about what x values we can plug in here. So negative numbers make sense and positive numbers make sense. So the domain is going to be that. Remember, the parentheses mean it's not included. We never get to infinity, so that is that's not included. Okay, now the range is going to be a little bit different. So for the range, let's think real quick in our table what happened with the y values and what they can be. So when we plugged in negative numbers, we get the same positive numbers over here. If I were to plug in -2 here, I would get 9. -3 would be 19. So that the parabola is coming back up. The question is, how low does it go for y? And the answer is it goes to 1. So the range is, it can be 1. And then it can go as high as we need it to. Okay, number 5, plot the points from the table. If they fit, draw a graph of the function on the grid below. Okay, this is definitely the easiest of the 5. So we're going to go -1 and 3, 0, 1, 1, 3, 2, 9, 3, 19, 4, 33, and of course this would continue up this way because it's quadratic. And there's the graph, and it's easier to actually see the range here. We can see that the lowest y value is 1. Okay, moving on, let's go on to 6. So for 6, we have to do the same thing as the pattern: linear, quadratic, or exponential. So for this one, we are going, let's see, we're going up by 1. And every time we do that, that's 3. And then from 1 to 6, no, that's not 3, that's 5. 1 to 6 is 5. 6 to 11 is 5. 5 and 5. So since the first difference is linear, it is linear. So we know that the slope here is 5. And I can easily spot the y-intercept in the equation as well. The y-intercept is 1. So it's linear because the first difference is linear, or is 5. What's the recursive formula? F of x is equal to f of x minus 1. So we get the next one. We take the one before it and add 5. This is equal to 5x plus 1. And you can just plug this in along here. You can see it works every single time. Find the domain and range. If this is our function, we know that domain can be anything. And we also know that the range can be anything. And now to plot the points, we are going to go -1, -4, 0, 1, 1, 6, 2, 11, 3, 16, 4, 21, and there's my linear function. Much easier than the first page, I think we would all agree. Okay, 11, let's look at what's going on. With this one, we're going from 2/3 to 2, 2 to 6, 6 to 18, and 18 to 54, times 3. So it is exponential because the first difference is a constant multiplier of 3. Find the recursive formula of the function. Find the explicit formula of the function. So our formula here, and we know this from last year, is AB to the x, where A is the start value, and B is the multiplier. So f of x is equal to start value times the multiplier to the x. The domain and range. The domain, we could plug any number. We can even do negatives because we've worked with negative exponents before. And the range, so even if we put in a negative exponent, we are still going to get a positive answer. Remember, a negative exponent doesn't make it negative. A negative exponent just makes it, oh, this isn't -3, this is 3. Or, no, it's 2/3. But we can use 3 as an example. So that would just equal like a 27th. So we could plug in anything, and the smallest thing we could get is 0. Bracket, parenthesis. And then the graph. Okay, the graph, all we have to do is just plot the points. So we got 0, 2/3, 1, 2, 2, 6, 3, 18, 4, all the way up there, 54. And you can see this jumps much quicker than the quadratic. So there is our exponential equation. Okay.